Hi everyone, in this video we're going to look at the first couple pages of your new packet, which looks like this, and it's called Linear Family. And what you need to know in the next, until the rest of the year really, we're going to study 8 different types of families, and they're all pictured on that front of your packet. And the first 2 that we're going to start with, you're relatively familiar with. So we are going to study the linear family and then together with the quadratic family. And you might think to yourself, hey, we've already studied these 2 things. Yes, we studied the algebra, how to manipulate equations. We haven't exactly studied their patterns. And so the more conceptual pattern recognition is what we're looking at for the rest of the year, and engineering more. What I mean by engineering is we are going to get very used to building things from building blocks. And so for the linear family, there's 3 building blocks that are popular for the linear family. And this is very unique to the linear family, and the quadratic family will have its own building blocks, the exponential family will have its own building blocks. But for the linear family, the thing that you survive on is memorizing this linear building block. So y minus a data point equals the slope, parenthesis x minus the x value of the data point. So m will represent your slope, your rise over your run, and then this y sub 1 and x sub 1 is just any data point, and I like using easy ones that I know, any xy value that's on the line. You also just a little bit of vocab that will make this unit easier. This would be what's called standard form of the equation, and what you notice is you have the x term and the y term on the left-hand side, and then just the number on the right-hand side. And then this is probably the most popular, well-known building block for a line, y equals mx plus c, where c would represent your y-intercept and m would be your slope. Sometimes you can cheat and just jump right to this if you're given the slope and the y-intercept, but this building block will work for every single line that you run into. There's a couple of weird lines that we run into. A vertical line would be one that runs straight up and down. So that would be an example, x equals 2. So if I go to Desmos and I graphed x is equal to 2, that has no slope. The slope is undefined. There is no rise over run. And then another weird line is a horizontal line, and that just means that we have no up and no down. The slope would be equal to 0, so that would be like if y equals 4. The slope would be 0, and it would just be y equals 4. So our parent function, that's kind of like, a parent function is the very, very basic form of the family. So in this case, the easiest linear function that you could have is y equals x. Remember from your doodle to art, f of x, this isn't f multiplied by x, it's f of x equals x. That would just be y equals x. And it would look like up 1 over 1, up 1 over 1, up 1 over 1. It would have a slope of 1, and then a y-intercept of 0 right there. And we could get all of our data points in our table, and we could label each of those xy values along the graph. So for instance, this would be the point, 1, 1, which is found in our table. The x value is 1, and the y value is 1. The very new thing that we get used to when we're engineering is being able to summarize the key features of the graph. So this would be our summary table for this. Our slope, our rise over our run, would be 1. If we had a parallel line to this, it would have the same slope, m equals 1. It might have a different y-intercept at different points, but it would have the same steepness, the same rise. Perpendicular, remember that would be your flipped fraction. So if your slope was positive 2, for instance, the perpendicular slope would be negative 1 over 2, the flipped fraction. An x-intercept happens when y equals 0, and then the y-intercept happens when x equals 0. So those will help us find their values. We can substitute 0 in for y to find the x-intercept, or 0 in for x to find the y-intercept. This is very new notation that we'll get used to, and it just means f and then a little apostrophe x, f of x, but with a little apostrophe. And the way that we pronounce that is called f prime of x, f prime of x. And the definition of f prime of x is the rate of change. So lucky for you, with the linear family, the rate of change is just the slope. So these two will be exactly the same for the whole entire linear family. When we get to different families, the rate of change will change over time. For instance, if you looked at this quadratic, here the rate of change, it's going down, it's negative. Here the rate of change is 0, and then here the rate of change is positive. But in the linear family, the rate of change is just the slope. It's constant the whole entire time. So that is what you need to know about the cover page and introduction to the linear family.